All right, so welcome back. This is a lesson I'm very excited to teach because we're going to start getting into functions, and this is the first chance we start getting into reusable code and just better organization. I'm very excited. So this is 2.1 void functions. Now, there are two types of functions we're going to focus on today. There are more types, but these are the two early types and the most important and most used. So let's start with what a function is. A function is a collection of statements that are grouped together to perform a specific task. Functions help you abstract complexity, organize code, and reuse code. Very, very important, okay? Now here we have two examples of functions. On the left, we have the functions that we're really going to be focusing on in this lesson. These are the void functions. They are a type of function that does not return a value. And what that means is that whatever is in the function just runs and nothing is returned after. So these three statements here, okay, these three statements will run every time the print function runs. Now, if you think about it with just three, that doesn't sound like a lot of simplifying, but if I made a function that, did 250 lines of code and I needed it all the time, then I can put it all in a function, give it a name, and just use the function name. That is awesome, okay? Now, the other type of function is a return function. It is a type of function that returns a value back to where it is called, okay? So you can see here, there's some numbers, there's some addition happening, and then something is being returned to where the function was called originally, okay? Now, this is the type of function that we will not be focusing on in this lesson, just because I want to really focus on starting to use function and thinking about what should go into functions. And when you start doing return functions, you open up a lot of additional things that need to be talked about, like parameters. So this is a separate lesson. In this lesson, we're going to focus on void functions. Okay, so how do we declare, define, and call a function? So first, let's start with what is function declaration and function definition, okay? A declaration is a statement that describes what the function will return, its name, and its parameters. A function definition is a collection of statements inside a function, okay? Now, most people look at a function and they think of the whole thing as one entity, okay? And in modern languages, they are really considered a single entity. However, in C++, we can separate declaration and definition, and you're going to see times where that's really important to do, okay? So here, again, what's declaration? Void print opening. That's a declaration. We said with void that it doesn't have a return type. So that's what void is doing here, okay? And that's the first thing that we put is what's the return type when you declare a function. The next thing you put is what is its name. Okay, so here's its name. And then finally, parameters will go inside these parentheses, but we will not touch that until we get to functions that return information, okay? Now, the definition is what's actually inside the function. It's these statements. This is the definition of the function. Now, here, it's all together, okay? Now, when you put the declaration and the definition together, notice how I had to put my main function below, okay? Which my main function is calling the print opening function here, okay? So actually, let's take a step back and not focus on that hierarchy for a second. Let's look at this function call, all right? To call a function, you simply use its name, the parentheses, and then a semicolon. And this one line will really run these two lines, okay? And I could go print opening, print opening, print. I could call as many times as I want to, okay? Now let's get back to this order, all right? The way the C++ compiler is going to work is it's going to go through your code in the order that it sees it. So if your main function is at the top, that means the compiler hasn't yet identified that print opening exists. So by putting the main function at the bottom, because this is where our code will start to run, when we compile it, it can find all of the functions and compile them before we actually start calling them, okay? So this order will matter if we declare and define at the same time, okay? Now, here on the right, you'll see that we separated our declaration and our definition. So here at the top, and this is done where we do our include statements, where we declare our namespaces. You can see that I just put the return type, the name, didn't list any parameters, and put a semicolon. So I declared this early. Notice how it's before my main function. So now the compiler will know, okay, there is going to be a function called print opening. We don't see its definition yet. That's fine, but we can compile without error. Okay. And notice how here I'm able to put the actual definition, which still technically includes the declaration, right? So that these line up. And I can actually give it what is in this function. Okay. So which one of these methods is better? Okay. At this stage, it doesn't really matter which one you choose. If you want to make sure that all of your functions are above, okay, you can do that. But things start to get weird, right? Things like, I always find it hard when I have to put functions in a certain order of where they appear. Because what if you call a function in here? Then its declaration and definition needs to be before, okay? So what I honestly would do is do this right method. It seems like it's the wrong way of doing things. It seems like it's much more work. But when we start doing multi-file programs and we start creating our own header files, the separation of declaration and definition will be in entirely different files. And then we don't even have to worry about the order, okay? So I would recommend this, but you can do either. Okay, let's do an example. Let's make some code and see what it looks like. So we have a file set up here, void functions.cpp. We got our IO stream, our namespace, and we have our main function. Okay, so you've been using main functions already. You've been putting all the code in there. It's no different. It's just now we're making our own. Okay, now I'm going to choose to do the method of separating my declarations. Okay, I'm going to put them all up top here. So I'm going to set a return type of void. Okay, and I'm going to do the print opening scene. So print opening. And I end it with a semicolon, all right? And then I'm gonna do another one. I'm gonna go, void, ask question, okay? Like that. I'm gonna do a print opening and an ask question, all right? And then I'm gonna call them. I already know that I'm gonna write these, and I'm gonna call them in order. So print opening and ask question. Okay, which at this point now my program will not compile because I have not given these any definitions. So let's go ahead and give them some definitions. So we'll do void print opening. Oh my goodness, okay. And this time it's gonna do something. So, you make an opening for a game. So, hello, welcome to my game, okay? Keep it simple for now, all right? And then let's do our ask question. So void ask question. And we can get input in these. We could do anything that we would do in a regular function. We could just do it here. So let me ask, for a string. So string, answer. I just gonna set it to a default of nothing. And then I'm gonna ask, enter your name. Okay, and so maybe this should have been like get username or something like that. Okay. Whoa, all right. And then we'll put that in answer. Now I know early on I showed you guys how to clear, get this a specific way to make sure you're getting the right stuff, to not add any additional code that we don't need for this new topic. I'm just not going to be doing that here, but I would suggest always making sure you check your input and make sure it's good. Okay. And then let's print it out to them. So you entered, a name. So you entered, let's do that. Okay, answer. All right, let's see what happens here when we run or compile this. Sorry, g++, void functions, .cpp. Okay, now I have my actual code. So hello, welcome to my game. Enter your name. It's Michael. You entered Michael. Okay. Now on the first glance, like you look at our output, it's like, oh, we didn't really do much anything different, right? But start to look at how much cleaner and more organized this code is. Okay. We have a function called ask question. Its name tells us exactly what this is supposed to do. It's supposed to ask a question. We have a function called print opening, right? It does one thing. This is very important about functions. You need to make sure that you make functions that kind of represent a single task most of the time, and that their names tell you what they're going to do. All right. And now look at how clean this main function is, right? Because your main function, which I should put my return 0, your main function here is going to tell you, or it's the start and the finish of your program, right? So you can tell that I'm starting up here and my program stops running when it gets down to here. You don't want 1,000 lines in your main function, because if you had 1,000 lines in your main function, then it would be really hard to see how the lifespan of your code. Okay, but now I can see it really clean. Oh, what's my program going to do? It's going to print an opening, it's going to ask a question, and then it's going to end. Okay, now if there's an error, errors are now super easy to find, right? So if you go, hey, wait a minute, my opening didn't print. What's wrong with my opening? You can go to your opening function and take a look. Okay, these functions help us organize and manage the complexity of our programs, and that's why I'm so excited for this lesson. The next part of our, sorry, I can hear my kids in the background. The next part of our code that we need to take a look at is function variable scope. Okay. Now, of course, when you start, adding features to your program that manage complexity, you also increase complexity in different ways. Okay. Before, you were only able to make a variable with a name once. And what I mean by that is you can only have one int x. And in fact, you can only have one x variable. You couldn't then make a double x, right? Or that would just be bad policy. Now, all of a sudden, look at this. We have a main function where int x is equal to 10. And then we have a do stuff function where int x is equal to 100. This is now okay to do. And it has to do with function variable scope. When you make a function, when you make a variable inside of a function, it only exists in that function. You cannot go and call it in a different function. So when this function, when do stuff is over, this x no longer exists. It's no longer callable. It only exists in do stuff. So because we made it within this function, we can have the same exact name. Okay. Now this can be tricky for people because when they call something a name, they want to be able to use it in different functions. And we have so many things to make sure that we can have information used in different functions. But for now, you got to know when you make a variable in a function, it only exists in that function. Now, how do we solve that for stuff we want in multiple functions? Okay. And so this brings a conversation of global versus local variables. Okay. A local variable is what we just talked about, a variable that is local to the function it was created in. So this is a local variable and it's local to main. This is a local variable and it's local to do stuff. Okay. Now global variables are a variable that is global to the entire file, meaning it can be used in multiple functions. So this global variable, notice how it does not go in any function, not even your main function. It's right up here with using namespace, which is why I left this part in here so you could see that. Okay. You need to put these on the main line of your program. Now, don't put them in between functions. Don't put them here. Put all global variables up top. So the way your program should read, you should have your includes, your namespaces, and then your global variables. And then obviously there's function declarations. They go right next to each other up here. Okay. But you cannot put statements here. You can't put couts, function calls. That's not what goes on the main line. Okay. Now, notice how there's a global variable x, there's a main variable x, and there's a do stuff variable x. Okay. Don't do that. Don't give a global variable the same name as a local variable. Okay. But let's just say that it happens. Okay. For whatever reason it happens, you should know how to deal with it. When you make a local variable here, which we have one called x, and you print out x, even though there's a global variable called x, this x will run. Okay. Inside of a function, key there, inside of a function, it's going to prioritize the local variable. Okay. Whoa. All right. Now, how do you actually get the global variable if it has the same name? You use the scope operator. Now, that's something we haven't seen in a little bit. It's the scope operator, okay? The double colon. Now, we used to use that before we started calling in the namespace, we would go, std, then we use the scope operator and call C out. The scope operator does exactly what you think it does. It helps identify the scope of where something belongs. So if you have a global variable with the same name, if you want to call the global over the local, you need to use the scope operator, okay? Now, again, see, look at all this complexity that's been introduced. Don't do that. Do not make a local variable and global variable with the same name. It's just bad to do, okay? And if you don't have the same name, then you don't need to use the scope operator. You can just call the global variable by its name, okay? That's only if there's the same name, okay? So let's actually dive in and let's really figure out how to do that so it doesn't seem so complex. Okay, so I made a lot of changes to this file. I have two function declarations, f1 and f2, and I'm going to call those functions in main, just back to back. And then down here, I've given them their definitions. So f1 is here. I've created an x variable. I've set it equal to 10, and I'm just simply printing it out. Now notice how in f2, I'm just printing out x. I didn't create anything in there, okay? I want to prove to you that they're separate. Look at this. Already, I can't even compile my program. X was not declared in this scope, okay, on line 21. So just a little proof here. When you create something in one function, it does not exist in the other. So I would need to go over here and actually give it a value. Okay, so now watch. I save, recompile, rerun. No problem now that I've actually given it a value over here. These are separate. If I change this one, okay, well, that's not going to print. Let me reprint it over here, right? Change this one over here. It makes no change to the other one. Okay, the other one is still 100 because I've only changed it in here. So we can, these variables are different, which means we can also reuse their name. Now let's focus on that global variable for a second here. I'm going to create up here with my function declarations. I'm going to create another in x, and I'm just going to give it 512, something very different. Okay, and then I'm going to create an int y. I'm going to give it 1001, something else that's very different. These are global. Okay, I can use them in every single one. So watch. I'm going to go in here and I'm going to print out. I'm going to say, hey, I'm in main. And then I'm going to print out that x and y values. So I'm going to go x and y. Okay. So, hey, I'm in main. I'm printing out the x value. I'm printing out the y value. Notice how in main, they were never created. Okay. Let's give this a compile. Let's give it a run. Look, we see 512, 1001. Now, I'm going to copy this. I'm going to go down to F1, and I'm just going to get rid of this change that I made here. And I'm going to say, hey, I'm in F1. Okay. Now look, I'm leaving this as X and I'm leaving this as Y. So I'm going to recompile, rerun, and look at this. Hey, I'm in F1, 10 and 1001. So you can see right here that when you're in a function, it prioritizes the local variable, not the global variable. Okay. Now Y worked just like Y worked because Y didn't have a duplicate as a local variable inside F1. There was only a global variable, so it can work. And notice how I'm going to multiple functions and I'm using them and everything's a-okay. Okay. So if you don't get too crazy with global variables, okay, not everything should be a global variable. Even if it's, needed in more than one function, okay, make it a global variable. But a lot of the times your variables should, be created and decreated and destroyed in the same function. Okay, now how do we fix this? Let's go to F2. Let's do this again. Okay, so I'm going to say, hi, I'm in F2, and I'm going to use that scope operator on X because there is a duplicate, and I want the global here, I'm going to say. If I use the scope operator, we should see it print out the global again. So look at F1 is still prioritizing, and F2 I'm getting the global. There shouldn't be a lot of reasons to do this, okay? But it's good to know a language in and out because this is the tools that you're going to have to solve problems. And you want to know as many tools as you possibly have. You never know when you might find yourself in a situation where this could just be useful to help debug something, not necessarily that you would put it in your code. Okay? So local variables only exist inside the function that they were created. Okay? Global variables will exist in all functions. They have to be made on the outside. Do not put those in between functions. Put them up top. Look, you can see include, namespaces, you got your function declarations, and then your global variables. Okay. Was this order that important? Not necessarily. This should be the first stuff you always do is your includes. These can really kind of be in any order. Okay. Now this is a short conversation on abstraction. Okay, abstraction is a huge, huge pillar of computer science. It's one of the most important tools that we have. You've been using it every day and don't realize it. Okay, now the main use of abstraction is, how do I say this? When you are printing something to the screen, you have no idea how that worked, right? Like you have no idea how it actually gets there, right? Like how does the terminal actually go, put some words in? Right? And how do those words actually make it to your program, right? If you had to, every time you wanted to write a program, had to go and make those tools by scratch, it'd be very difficult to code. So that is abstracted from you so that you can focus on the things that you want to do. That's the big purpose of abstraction. But we have a lot of other smaller ideas in abstraction. And here is function abstraction, the process of using functions to manage complexity. Functions allow us to break things down into little pieces and separate their complexity. So now look at your main function. This is really like your main functions should not be very big. Okay. Like look at how small this is. Opening scene, next scene, final scene, end of program. Now you can kind of go through and watch what's happening. At most, because you don't know, return statements yet or parameters to pass information between functions yet, at most at this point, you can do control logic in main, like asking user questions and sending them to different functions and then going back to your main function. That's okay to do, okay? But we want to keep this as clean as we can, okay? All right. Let's dive into our quick code example, okay? So we have a quick code, we're doing calculator word functions and a big stipulation here. I know we're seeing a lot of calculators, and the reason why you have a lot of calculators right now is because I want you to be focusing on the new tools that you're learning, not necessarily a complicated problem that you're trying to solve with those tools yet. Okay, so you're gonna see a lot of calculators or math type things in this unit, and that's okay. So you're gonna create a calculator using functions. You need to have a function for 3 out of 5 of the main operators: add, subtract, multiply, divide, modulus. Pick 3 of them, make a function for it, okay? Now get the user input for those in the function, okay? So you must have a function for 3 out of 5. So, let's say the user picks add, okay, call the add function, and then in the add function, get the numbers to add, okay? That way all that complexity, everything needed for add is inside add. 3. You must have a function for 3 out of you must have a function for 3 of the functions in CMath. Choose any 3: power, round, square root. Okay. Then 4, you must have a function for 2 formulas that you choose. And these are just examples: Pythagorean theorem, distance formula. They don't even have to be that complicated, but I want you to do something more than just this built-in stuff. Okay. Choose a formula in your math class or something. Nothing too crazy, unless you want to take an advanced opportunity to choose complicated formulas. So I've mentioned in the past that I will be doing more advanced quick codes. For this one, there's just an advanced opportunity within the quick code. For for loops, which is the next lesson, there will be an opportunity to do some more advanced, a whole separate quick code. But this one, if you want to make this more challenging, then choose more challenging formulas. Now, finally, your main function must be kept clean. It can serve as the main control board, interacting with users and calling the appropriate functions. So what do I mean by this? All right. Your main function, this is where you ask the user, hey, what operation do you want? Add, subtract, power, square root, Pythagorean theorem. Then they answer in the main function. you check their answer, and then call one of your other functions. So it's like the main control board. And that's okay for now because we don't know how to share information between functions, okay? So let's give you guys an example of what this is going to look like. All right, so, whoa, you can see a little bit of the code. All right, so here's the deal, all right? We are going to show you how to do the quick code, all right? Well, not how to do the quick code, but you guys know what I mean. Just an example. So would you like to add or calculate the slope? Obviously, yours is going to be much longer than this. Mine's a little bit more simple, just to give you some idea. So I chose add. I'm going to enter in 3 and 4. I get 7. All good for add, okay? Now this was in my main function. I asked them, the questions, I checked the input, and I directed them to the right function. So this all came from a function called add. Now I run this again. I'm going to choose slope, which is for the slope formula. So enter your x1 and your y1 point. So, 10 and 5, and then let's go 5 and 10, okay? And I get -1. All right, so I did the y2 minus y1 over x2 minus x1, and I ended up with this, okay? Now this was, you don't have to do the slope formula, but I wanted you to see that we can start to do a little bit more complicated things, okay? So maybe choose something from your math class. I think that'll, make your math class a lot easier, okay? Now I'm gonna show you a little bit of my main function because I want you to get an idea here, okay? Look at my main function is just logic. I'm asking them the question, and then I'm directing them, look at that, directing them to the right place. I'm calling the function. So now, if I had 10 of these, it would be super easy to see. Because in your previous, calculators, you would ask them this, and then you would do all the work right here. And so then if you had any logic there, you had more and more if statements inside if statements inside if statements, and it just starts to get too crazy. So now all of a sudden it reads really well. They said add, call add. They said slope, call slope, and those functions are hidden above. Okay, so hopefully this gives you a good idea of what to do, and good luck.